I'm very pleased today to be joined by Matthias Mersmann, who's the Chief Technology Officer of KHD Humboldt Wedag. And he is actually one of our delegates for our digital festival in January. And I pinned him down ruthlessly to join me for a podcast episode. So Matthias, perhaps could you just give a little flavour to your background and where you're coming to decarbonisation from?
Yeah, first of all, thanks very much for pinning me down so ruthlessly. I really enjoy being part of your podcast. Myself, I have a background in the cement industry for over 25 years. I have, during that time, always been connected to issues of technology, technological development, designing machines and processes for the production of cement, and always have been looking at doing that most efficiently with least possible energy demand and least possible ecological footprint.
When you and I first talked, obviously your role in the cement sector is as you said, to provide that kind of essential equipment, but it also sounded like you're coming at this from a position of someone who is looking for potential partners so that we can integrate your systems with decarbonisation solutions. Could you just explain a little about what you're looking for over the next year or so?
That is true. We have to explain that for a period of maybe 5, 6, or 7 decades, the way cement plants were built did not really change much. Of course, there were some innovations, which I don't need to list all here, but when we're looking at the challenge ahead in the context of decarbonization, the cement industry is probably looking at its biggest challenge, which it has ever faced. It's not like the cement industry wasn't aware of its carbon footprint. I guess the first works have been conducted already more than 20 years ago in the cement industry, targeting at getting a hold on the numbers in CO2 emission, and also developing technologies to reduce the CO2 emissions. But with this whole process getting increasingly dynamic in terms of decarbonization, and the situation is really getting pressing according to the Paris Agreement and all the political power that is on the streets in the political area, it's getting ever more concrete. And the cement industry has been working quite a lot in reacting on this by shaping new processes, new pieces of equipment, but still this is going to lead into a considerable technological revolution in the equipment, in the processes, in the plant technology for the manufacture of cement. And for the first time in, I guess, the history of the cement industry, the engineers and people and specialists in the cement industry are faced with the absolute necessity to close technological and business bridges to technologies and other industries which have formerly been separated quite distinctly from the cement industry. We're now talking about integrating technologies that were previously completely separated from the cement world. So that is a challenge, and that is what we have to accomplish, closing that bridge.
We will come back to sort of talk a bit more about that, but let's sort of just take a step back, because I'm interested in your perspective, because although you are very much embedded in the cement sector, you're not the producer, you are the partner to the producer. So from your perspective, what is it that's slowing or inhibiting decarbonisation right now? And to what extent do you think it is, technological versus organisational versus, financial? Tell me a bit about your viewpoint on that.
I don't think there's a clear answer to that already right now. In the end, I guess, what is needed for an accelerated decarbonization is, in the end, stiffer political regulation, no matter through what instrument that is being reached, whether it's, say, a reduction in CO2 emission allowances or a carbon tax or whatever instruments there are. The situation today is that most of the possibilities, the pathways for reduction of carbon footprint of the cement industry are in the end calling for investments, and the production price per ton of cement product will suffer badly from most of the instruments which would have to be utilized. Some of them are not exactly free of charge. Some are coming even with a financial benefit. If we think about the combustion of alternative fuels, for example, that is even to the direct financial benefit of the cement producer. But the other pathways, which in the long run would deliver the right decarbonization potential, are calling for higher investments. And as long as there is no incentive, or put it in other words, if there is no force, then the cement producers, of course, will back off and will not realize that.
So it either needs the, as you're saying, the kind of incentive or disincentive, depending how you look at it, of tax or something else, or a much stronger market pull than we're really seeing yet.
That is true. But I have to say that throughout the last maybe 1 year or even less than 1 year, I recognize a very strong dynamic situation. All the market participants of the cement industry have been stating very challenging positions, very strong commitments to reduce their carbon footprint, both near term as well as long term. And there is a range of roadmaps that have been developed by several institutions like the World Business Council for Sustainability, Cement Sustainability Initiative, International Energy Agency, CEM Bureau, which were on your podcast as well. I guess they presented their roadmap as well. So the industry is prepared with a rough way forward, an idea about what needs to be done. And they are committed to do so. Still, in order to actually materialize what is being outlined in those roadmaps, it still needs another push. But I'm sure this push is going to come. And the cement industry is prepared to get going. However, we need to understand that it's 5 minutes to 12. We need to get going now because the next years are going to be decisive in order to develop these technologies, which we're going to need further down the road in order to actually really achieve the limitation of the CO2 budget, which we still have in order to reach the Paris Agreement.
So does the kind of the work that, you mentioned CEM Bureau as an example, or the IEA, those roadmaps, has that kind of pushed the pressure down sufficiently so that you and your teams are hearing about it from the producers? Or are you interested in it or coming at it from your own drive, your own push to find partners that you could collaborate with?
Of course, our customers, which is the cement producing industry. We are the equipment supplier who supply the equipment for our customers to produce cement. Of course, our customers are first-hand addressees for the reduction of CO2 emission reduction. But of course, they are going to turn back on us and ask us, hey, can you supply equipment and technology that allows us to reduce our carbon footprints? And we want, of course, to fulfill these requirements, and we want to supply these pieces of equipment to our clients. So in the end, we're all in the same boat. Everybody comes with his own driver. Our driver certainly is first-hand driver is to fulfill the requirements that our clients are asking from us. And second, of course, to be part of that improvement, to be part of that activity to reduce the carbon footprint of the cement industry. So in the end, we're in the same boat. I think the industry has, and maybe that is a big step forward, the industry has understood this. While I remember when I was first working on CO2 reduction technologies more than 10 years back, and we figured out that, for example, CCUS technologies would add another, say, 80, 90, 100, 120 euro cost per ton of clinker, and we reported these results, everybody said, "Are you crazy?" The production cost of a regular ton of cement in Central Europe may be only ranging between around 40 or 50 euro per ton, even lower. You can imagine that this cost increment in production cost is far away from being realistic. However, throughout the last year, I think that there's an increasing sense of common agreement to the necessity to actually go down this road. We'll have to do something about it. It's going to cost investment, it's going to cost money. All the more important it is that the political framework contains some elements to safeguard the necessary investments for our clients, so that they can work on a level play field, maybe with carbon borders or whatever is possible, in order to allow the industry to make that investment without being wiped away then through carbon leakage.
There are enough challenges to getting an industry to change without them forcing them to change in a way that is just purely uncompetitive and, not to provide support around that. Although I did see after that podcast, actually, on our LinkedIn feed, some kind of back and forth about the fairness or the reality of carbon border mechanisms and things like that. So there's still a lot of conversation and I say disagreement, but sort of different positions around that, I think, to be resolved. So you mentioned CCUS. One of the things, we have talked about on some of these podcasts is the most important technologies or the most interesting technologies that people are seeing that could really affect the acceleration of decarbonisation. It's not just technologies that can possibly decarbonize, but technologies that can actually accelerate that in a meaningful way. So CCUS, a strong contender for the cement sector. What else are you seeing that you think is interesting or that has real potential?
Yeah, that's true. In fact, there are, I would say, roughly 5 pathways which are relevant for the reduction of the carbon footprint of the cement industry. And these 5 pathways, more or less, are the synthesis of the many roadmaps that have been developed already. And some of those are readily available already today. Some of them have still to be developed. They all come in different, not only technological readiness levels, they also come with different cost requirement. They also come with different potentials. And in order to organize well-structured and efficient decarbonization, I think it's of paramount importance to find out a way to implement these different technological pathways in their best suitable sequence and their best suitable form of application. For example, we cannot wait until we have CCUS ready. This will require another, 5 years, 6, 7, 10 years before we have CCUS in the sufficient volume ready for use. We have the first pilots being installed right now. And if you remember, or if you look at the time to market specifics in our industry, it takes some 10 years from the idea of a technology before you have that ready for implementation in the real world. So it will take some more 5 to 10 years, maybe even longer, before we get CCUS technologies really visible in the market. So there are others, like increasing the use of alternative fuels, which can also remarkably contribute to the decarbonization. And this is available technologically already today. If you look at Europe, I guess we have an average utilization rate of 48%. Using secondary fuels, which means waste-derived fuels for the production of cement. In Austria and Germany, we're up to 70%, But in other parts of the world, we are just beginning to do that. So there's a huge potential in exchanging the fossil fuels by most biogenic waste-derived fuels. And that can also make a very valuable contribution. We can start right away doing that. Some cement plants need some technological modification to it, but we're ready to go for that. Next one would be with the big lever, the substitution of clinker in the cement recipe. In say ordinary cements, most of the cements, they contain 95% clinker. Clinker is what is really CO2 intense. So if we find ways to put more of other cementitious supplementary materials into that cement mixture, we can almost immediately reduce the carbon footprint of the cement production. However, technologically, we are quite well advanced. However, the problem is that we need these cements, which are then produced with a lesser amount of clinker, to be fulfilling the quality standards of the several building material, say, regulatory bodies in the world. And that's a big issue. These quality and regulatory bodies in the world, they need to test these low clinker cements on durability. And, durability contains the word long term. And it's not so easy to release such a new type of cement for building, say, skyscraper structures or massive buildings without going the risk that these buildings and structures are prone for collapsing and all these quality and safety issues. So it's a very complicated field, and it one more time shows that we need the collaboration of many different disciplines and many different people who are all involved in finally producing and using mankind's most produced product, which is cement.
I know one of the other, it was not a cement specific discussion I was having, was kind of alluding to the fact that one of the biggest challenges for decarbonisation is the fact that we're also used to living and working in quite linear systems. So someone does A, it goes to B, B looks at it, sends it to C, C decides if it's got regulatory, and it's that kind of approach that, in a way, a systemic change is needed as much as technological or these other things. But I suppose that just then produces so many drives for change. It must, it's hard to imagine how we could really achieve that. But yeah, definite challenge there. So that was CCUS, alternative fuels, substitution of key materials. What else is on your kind of, in your line of vision as important technologies?
A very basic one is, of course, always to increase the energy efficiency of the production process as such. That is clear to see. The production of cement is one of mankind's most energy-intense production processes, and it produces mankind's most produced product. So from that, we can see that any improvement in the reduction of fuel demand for the production of cement and for the production of cement clinker is always going into the right direction. We estimate that for example, in Northern American markets, in Russia, in China, and some other areas on the world, we still have quite a good potential to reduce the fuel demand for the production of cement clinker, while in Europe and in Southeast Asia, for example, in India, the plants have already reached a level of efficiency where there is no much potential more to be raised. So in average, maybe worldwide, there is a potential of maybe 5% additional saving in energy efficiency increase. Then there are some other technological ways. One may be worthwhile naming specifically that came up during the last, I would say, 2 years only. So we can see that engineers are still finding out new ways, even though the cement industry has been looking at this already for decades. The recarbonization of spent concrete is another interesting idea. If you think of closing the cycle, and recycling is always a good approach for any sustainable approach for reducing ecological footprints. Now, the elegant thing about this is if you want to produce cement, you are driving out CO2 from limestone to produce cement. Now, if you produce concrete from that cement, and later on, after that concrete building has been demolished, maybe some years later, you take that concrete and you reverse that process. So you put that CO2 back into that concrete as you have been driving out that CO2 during the production of the cement. So that's interesting. And it's an idea that closes the circle and can provide some good potential. However, again, the trouble is in detail. You can imagine if you want to use that spent concrete as a carbon sink, you need to transport this spent concrete to that place where you can put the carbon back in. So it's a logistical problem. Like we have to say, all of those technologies are to a big extent driven by logistical factors. That is one of the very decisive elements in the cement industry anyhow. The cement as such is a very low cost product. A ton of cement costs maybe, depending on time and market and region, but let it cost $50. And the transportation of this heavy material is very costly. So there's a rule of thumb that maybe within 200 kilometers, that is the radius of your cement business. Because if you exceed that, the transportation costs are so high. And this also applies to all the decarbonization measures. Like if you capture CO2, what do you do with it? Do you have a sink close by? Do you have a cave where you can sequester it? Or do you have a methanol plant close by? Or do you have to transport it through 5,000, 10,000 kilometers? This is one of the big challenges in actual materialization of all these ideas. These ideas are technically there, but to make them feasible, that's a very project-specific undertaking.
I think sometimes when people talk to me about the scalability of a given technology, I tend to be quite black and white about it. But I sort of think, well, it is proven at scale because it's modular or it's this, but actually that kind of idea of, is it scalable? Is the full value chain associated with it scalable? Is it there? And the answer is not yet. Not yet. It is not proven that if you've got, I don't know, a plant in somewhere in Central Europe that you can easily transport that CO2 to be part of one of the cluster initiatives might seem obvious to others, but that is part of the at-scale question, isn't it? Not just is the technology scalable, but is the whole landscape at scale?
Absolutely, absolutely. That's vital. I think technology-wise, we may be already oriented towards what should be possible. So engineers will be very busy in developing this to actually materializable state, technology readiness level 6, 7, 8. That'll be okay. The question comes from the economical feasibility. And this economical feasibility is demanding a cooperative approach from policymakers, from businessmen, from market. Not on technology may be the least problematic field here. It needs to be feasible. It's not possible that the cement producers will have to spend 2, 3, 4 times the money for producing their product. They will not be able to survive. So it needs an individual feasibility for each cement producer. And when I say cement producer, I don't mean the huge companies that are running 100 or 200 cement plants. Each and every site, each and every factory needs to be able to produce economically feasible. And that is depending on a lot of local factors, which makes it hard to develop a scalable blueprint, which you can cover the whole industry with.
Well, let's go back. So when I introduced you, I was saying that one of the things that was kind of interesting about your perspective on this is that you're very much looking for those collaborations and partnerships. You know, you're not bringing a CCUS technology to market. You are looking for technologies and partners that you could present as more of a multi-party offering, I suppose, to your core client base. So tell me a bit about what do you think is going to be needed from those sorts of collaborations for this to work? How might you find the right companies, or how might those collaborations come together, and what's going to be needed from them?
Speaking technology first, we have to change the way cement clinker and cement is being produced. We have to change it against a history of more than 5 or 6 decades. So we have to integrate technologies which had been separated from our realm of knowledge so far. Specifically, I'm thinking in the direction of electrolysis, the whole technology that comes in connection with the hydrogen technologies, oxygen technologies, methanol, methanolization. So that goes into the direction of the chemical engineering specifics. We have to line up with automation specialists because by integrating these technologies into the core cement production process and core cement production and equipment, it needs certainly new control regimes. We need to line up also beyond the technological field of cooperation. We need to line up with people who develop the new business models, people who are networking in carbon utilization streams, sequestering streams. We might need to line up with people who know about pipeline, all kinds of things. It's such a huge area which we have to find our way through that it is hard to name it already in a ready to print form. So I need to meet these people and then develop together with them a possibility to be able in the future to supply equipment and plants and technological structures to our clients, which they want to produce their cement with in the future.
Do you see that those other kinds of groups are open to the conversation, or are people still perhaps a little more siloed in that kind of old-fashioned way? What are you experiencing when you're looking around and perhaps talking to people from those different sectors?
I have to say I'm really excited, to be honest, because I feel there's a new spirit, there's a new movement, there's a new understanding in the community of engineers, I would say, at least as far as I can overlook it. Have engineers often been quite conservative, quite protective about their way of making business, about their scope of technologies, and executed their business inside these frames. I feel that recently, and under the impression of this new thinking, engineers are opening up much more than they did before. And in the end, I guess this is the spirit why people chose to become engineers in the very beginning. If you ask engineers which have graduated from university, about what they wish for them for their job to be. Everybody would say, I want a job that is interesting. I'm doing a lot of different things every day, no boredom, a wide field of technology. This is what they all want to do. And then they go into the real working life. And if you ask them 5 or 10 years later, you probably get a lot of people answering to you, well, better not change anything. It's all working in here. We'll never change a working system. But this is not the spirit why people become engineers. Engineers want to do something, create something. And I feel really a revival of this spirit lately.
I know I come at all of this as a kind of lay person coming in from the outside, but I really sort of even sense from conversations I had at the start of year to now that there is more momentum somehow, more excitement in places where perhaps, I don't know, I definitely sense that. If I think back to some of the earlier conversations I had with one or two people who I've caught up with more recently, and it feels like there is just that sense of perhaps it can be a positive outcome from COVID, which is a shrugging off of something and that willingness to move forward and invest in something, not just invest money, but invest time and energy in something new.
Absolutely. I think it's absolutely true. I have the same feeling, and I guess the two of us were not alone. It's like people are sensing it can be real. It can be real. While it used to be so far away, when I started working on oxyfuel and carbon capture over 10 years ago, and we ran out with this result. It costs $100 per ton of clinker more. It was immediately pushed aside, and it was
Straight shut down.
It was away from reality, and everybody who was involved in that knew that it's going to happen. Everybody knew that the carbon footprint of the cement industry was that high, 6, 7, 8%, depending on who you ask, of all man-made CO2 emissions is from the cement industry alone. Everybody who is dealing with this in the cement industry knew it's going to happen. We cannot escape from that. And someday we are going to be confronted with it. But it kept on lingering far away in the horizon, and it never got the feeling that this is going to be real. And this has changed. I guess throughout the last 1 or maximum 2 years, it has changed. People are becoming aware of the fact that it is going to be real. And at the same time, it's always a little bit like whip and sweet bread. We need at the same time also to do something. But at the same time, we also feel like it's becoming real. It is possible. It has a chance to be getting real.
Well, Matthias, thank you so much for talking to me. I really enjoyed that. And it was nice to have a sort of combination of the practical and also a little philosophical. That definitely always interests me. So thank you very much for coming along today.
Thank you very much, Alex. It was my pleasure.